my first question to you guys is what are quadrilaterals? What is a quadrilateral? What are they? So in the chat, quadrilaterals. You can just type an answer. Let me know what you think a quadrilateral is. Try and be quite descriptive in your answers, just that we know what's going on. There we go, descriptive. I'm impressed that you typed that so fast, I must be honest. Okay, nice, guys. Right, so if we just break up this word, so this prefix quad, don't know what that looks like. Prefix quad means four. Okay, so we can relate this four like we did with triangle and tri in a couple different ways. The first characteristic of a quad is the fact that it is a closed 2D shape or a plane shape. I think Zintley put that in there. That has four sides. Now, guys, you can get irregular quadrilaterals. So you could get something like that sort of situation. That's still a quadrilateral, but we're going to focus on regular quadrilaterals. So it's not going to have any like concave or any like dents in it. Another sort of interpretation of this idea of quad and four is the fact that we have four interior angles. And a couple of you actually put on the chat, these four interior angles add up to 360 degrees. Yep. Okay, so like on a basic level, we're not even starting to talk about special types of quads. On a basic level, a quadrilateral has four sides, four interior angles that add up to 360. So anytime you have a quadrilateral, a regular quadrilateral, you can assume that these things are true. It's going to have four sides and the interior angles will add up to 360, which is great, but we don't work with just a four-sided shape. We start to work with more specialized or more specific types of quadrilaterals. And those are what we're going to have a look at today. So Zintley mentioned a couple already in his explanation: parallelograms, rhombi, rectangles, kites. All of those are special types of quads, and we need to know their characteristics. Okay, so we're going to have a look at these quadrilaterals. And like I said, I'm going to sometimes ask you to raise your hand. I'm sometimes going to ask you to put on the chat. Just listen out for what the instruction is, and we will be A-okay. All right, so guys, the first sort of quad that we're going to have a look at is trapezoids, or sometimes we can call these trapeziums. I actually don't call them trapezoids. I call them trapeziums. Don't know why I then put trapezoids there, but it doesn't matter. So trapezoids, trapeziums, doesn't really matter. Synonyms for the same thing. So on the chat, can anyone give me a characteristic that all trapezoids or all trapeziums have? What is their unique or their defining characteristic? Remember, we already know it's a four-sided shape, and we already know that all the interior angles add up to 360. What makes a trapezium a trapezium? I'm starting to get a slow trickle of answers. I know you guys know this. Let's see. Nice. Okay, so guys, our defining characteristic of a trapezium is the fact that we've got one pair of opposite sides parallel. Now, okay, tonight I'm not quite able to write and talk, so that's going to be fun. Alrighty, so guys, remember on a diagram, parallel we represent with the arrows. So we've got one pair of parallel sides. That's really all there is to a trapezium. Some trapeziums have no equal angles in them, as some of you have said. But what I do want you to take note of is that we do get what we call isosceles trapeziums. And this one is slightly more specialized than just your basic trapezium, because not only does it have the one pair of opposite sides parallel, it also has, so the non-parallel sides are equal in length. So in an isosceles trapezium, our non-parallel sides are equal. And that also then means that the angles opposite those equal sides, okay, I'm going to try to spell angles properly. Are equal. So this angle is equal to this angle. So we get a slightly more specialized trapezium called an isosceles trapezium. But at the end of the day, guys, the defining characteristic of a trapezium is the fact that we've got that one pair of opposite sides parallel. So trapeziums we use sometimes, not very often. It's not to say we never use them. We do definitely use them. And the defining characteristic that we need to know is the fact that we've got that one pair of parallel lines. Chantal, I don't quite know what you mean by line of symmetry. In an isosceles trapezium, we'll definitely have a line of symmetry, but not necessarily in just a basic trapezium. But in an isosceles trapezium, definitely. Right, so guys, I'm just going to wait here for you to take a screenshot of this. And then we're going to start looking at more and more specialized quads and what their characteristics are. So the next one that we're going to have a look at is a kite. So start thinking about any characteristics of a kite that you know about. And I think for this one, I'm going to ask you to raise your hands. So screenshots here. Okay, so next quad we're going to have a look at is a kite. So if anyone wants to raise their hand to give me a characteristic of a kite, that would be wonderful. Kululeko? I don't actually know if I did. Here we go.
Hello, ma'am.
Hi.
Ma'am, the characteristics of a kite, no sides are parallel and both pairs of adjacent sides are equal.
Okay, cool. So let's start with, in a kite, we have no parallel sides. And the next thing is that we've got two pairs of adjacent sides equal. Now, guys, remember adjacent means next to. So many words, right? And so these two sides, I don't like that, are equal, and they're also adjacent to each other. And those two sides are equal, and they are also adjacent to each other. Right, so we've got adjacent pair, two pairs of adjacent sides equal. Lubanzi, another characteristic for me?
One pair of opposite angles are equal.
Good, so we've got one pair of opposite angles are equal. And guys, these will be the angles in between the non-equal sides. So this angle is between non-equal sides. This angle is between non-equal sides. And so those are the two angles that are equal to each other. We're just going to put that in there. So between the non-equal sides. Hello. Right, Chantal, another characteristic for me?
Yes, ma'am. One line of symmetry.
Okay, nice. Okay, so we have one line of symmetry for our kite. And guys, these lines of symmetry are often diagonals. So if we draw in our diagonal, so from one corner to the opposite, that would be our line of symmetry. So if I folded my kite over, I get that mirror image. Very nice, Chantal. But remember, guys, we do also have a second diagonal from one opposite vertex to another. Right, Legilwe on the chat very nicely has put the longest diagonal bisects the shortest diagonal. So I'm going to write here that we get one diagonal bisected. And grade 8's bisect means cut in half. Bi means two, so sect means cut, so cut in half. One diagonal is bisected. Bisected. And as we said, the longest diagonal cuts the shortest diagonal, so that is going to be the one cut in half. We have another characteristic, and Agilwe has again said it. So another characteristic that we need to know here for our kite is the fact that the diagonals intersect at 90 degrees. And so where those diagonals meet, essentially, remember we represent that with that square. Now, guys, that's important because basically what happens is if you're drawing your diagonals, you end up with 4 right-angled triangles. And when we have right-angled triangles, if now, for example, we get to measurement and we start talking about finding a missing length, theorem of Pythagoras then becomes quite important in a right-angled triangle. So we need to start making all of these connections with the information that we know and information that we're eventually going to learn in order to start applying or using the characteristics of my quads. All right, so those are your important characteristics of your quads. We've got one more that we haven't mentioned, and that's the fact that the unequal angles, the unequal opposite angles rather, are bisected by the diagonal. Okay, and so what that means is that the angle at the top gets cut exactly in half, and the angle at the bottom gets cut exactly in half. Okay, so the diagonal cuts the non-equal angles in half. Right, and again, so if like you think back to the geometry that we've been doing where I've asked you to find unknown angles, if you now get given a kite, and you know that it cuts it in half, you can potentially use that information. So again, guys, what we're doing here today is we're just learning about the characteristics that will eventually become useful to us. All right, so take your screenshots of your kite characteristics. As you can see, the next one is parallelograms. So start thinking of your parallelogram characteristics that we need to know. And guys, because I am pretty much, or we are pretty much just putting information down, if you have questions, please just ask them throughout. I'm not going to stop and say if anyone has questions. It's just information. So if you do have a question, put it on the chat and I'll deal with it, okay? Alrighty, so parallelograms. And this is now where we start dealing with quads that we're going to use quite often. So a parallelogram, from like grade 10, we use parallelograms a lot, especially in geometry sections. Okay, so we need to know our characteristics here. So I can see some of you are already putting it on the chat. I'm going to ask if anyone wants to raise their hand and give me a parallelogram characteristic to please do so. I would like to hear your voices. Luanle.
Hello, ma'am.
Hi.
How are you?
I'm good. How are you?
I'm also good, ma'am. So, ma'am, the first reason I have, ma'am, is the opposite side of a parallelogram are equal.
Sorry, can you say it again for me? You broke up a little bit.
The opposite side of a parallelogram are equal.
Perfect. Okay, I'm just going to actually rephrase what I've said here. Both pairs of opposite sides are equal. Both pairs of... All right, so that is our first parallelogram characteristic that we need to know, the fact that opposite sides are equal to each other. Nice one, Lei. Thank you very much. Omfa, next one, or another one rather. Omfa, are you there? Okay, I'm going to move on. Just remember your hand is up. Chantal?
Ma'am, angles add up to 360 degrees.
Okay, good. So guys, remember in any quad that we work with, if we add up the 4 interior angles, we will get 360 degrees. I'm going to come back to that in a second once I have another characteristic. Any others, Chantal?
Ma'am, opposite sides are equal. Opposite sides are equal to sets of parallel lines.
Say the last little bit. Opposite sides are equal and?
And 2 sets of parallel lines.
Okay, good. So guys, not only are both opposite sides equal, both opposite sides are parallel. And remember, we illustrate parallel with the arrow or arrows. Where the name, that's not how you spell parallel, is it? This is actually where the name of parallelogram comes from. The fact that we've got these 2 opposite sides parallel to each other, we have a parallelogram. Lubanzi, another characteristic?
Hi.
Hi.
Opposite angles are equal.
Perfect. So both pairs of opposite angles are equal. And so what that means is that this angle is equal to this angle, and that angle equal to that angle. The opposite angles are equal to each other. And so now to just quickly go back to Chantal's point of all angles add up to 360. Like I say, that's true of any quad. But also bear in mind now that you've got parallel lines and you've got a U shape there. So we also now need to start applying our geometry reasons and thinking about the fact that we have co-interior angles here as well. Okay, guys, we definitely have some more characteristics. I'm going to head to the chat because I can see we've got a couple there. So quite a few of you have said or spoken about the diagonals, the fact that the diagonals bisect each other or cut each other in half. So let's add that. Our diagonals bisect each other. So guys, unlike the kite where only one diagonal is bisected, in this case, they actually cut each other in half. All right, so this diagonal gets cut in half. I don't like that. Let's try that again. And this diagonal gets cut in half. So the diagonals bisect each other. Whoops. Omfa, I see your message. That's absolutely fine, no problem. Okay, so guys, parallelogram is and so again, we now need to start linking it with geometry, parallel lines. What does that all mean? And eventually when we do get to measurement, how do we work out the lengths, or how do we work out angles, etc., in a parallelogram? All right, so I'm going to stop here, take your screenshots. I'm also going to just take this opportunity to make sure I haven't missed anything in the chat. I don't think so. I did have a squiz, but just make sure. Nice. Okay, so as you can see, our next example, our next quad that we're going to look at is a rectangle. So I'm hoping you've all taken your screenshots. Let's discuss rectangle. So anyone want to raise their hand and give me a characteristic of a rectangle? Omfa, I see your hand. Let's go.
Hello, ma'am.
Hi.
A rectangle has 4 equal angles. They all
Okay.
add up to 90 degrees.
Okay, sorry, just say it again. Did you say a rectangle has 4 equal sides or 4 equal angles?
Angles.
Okay, good. So all 4, whoops, interior angles are equal. Now, if we just think about what that means, a lot of you are constantly saying angles in a quad add up to 360. So let's apply that for a second. If we know that all 4 angles must add up to 360 and all 4 are equal, if we divide 360 by 4, we get 90 degrees. And so what that tells me is that all of these interior angles are 90-degree angles. Nice, Omfa, well done. Mutletlego.
Hello, ma'am.
Hi,
How are you?
I'm good. How are you?
I'm good. It says opposite sides are parallel.
Perfect. Okay, so guys, the next characteristic we have here is that both pairs of opposite sides are parallel. Now that should remind you of a parallelogram. Like I said, I can't write and talk tonight. That should remind you of a parallelogram. And so what that actually means is that a rectangle is a special type of parallelogram. So our opposite sides are parallel to each other. And again, a rectangle is therefore a special type of parallelogram. Jason, I'll scroll back up later, so just hang on. Lubanzi, what else do we have?
I'm back again. Ma'am, opposite sides are equal.
Good. Okay, back again with all the knowledge. So both pairs of opposite sides are equal. I hope I heard you correctly.
We understood on our side. Just
Right, so we've got both pairs of opposite sides are equal to each other. Perfect. Chantal, what else?
Ma'am, there are 4 right angles.
Perfect. Okay, so if we have a look at the pinky purpley, we've got our 4 right angles in our rectangle. And again, guys, this goes back to those parallel lines. They're all co-interior. Anything else, Chantal?
Ma'am, 2 lines of symmetry.
Okay, good. So guys, again, we've got those diagonals in a rectangle. Okay, now what's special about these diagonals is that they're equal in length. And not only are they equal in length, they also bisect each other. And so what that means is that when we cut these diagonals in half, all of those parts are actually the same length because they're equal. So Chantal referred to a line of symmetry. I don't know why my brain is struggling to get there. In terms of, okay, so guys, lines of symmetry, important. We don't focus them on English. But your lines of symmetry here would be cutting it exactly in half, vertically and horizontally. That's what you meant, Chantal?
Yes, ma'am.
Good. Okay, so we do have lines of symmetry, especially with these more specialized type of quads. And guys, remember, line of symmetry is where it creates that mirror image for us. So when we start talking about sections like reflections and rotations and stuff like that, those lines of symmetry are really important. All right, I'm just going to double check the chat and make sure I haven't missed any characteristics. Seems not. So take your screenshots here of the rectangle. So guys, hopefully what you see here is that a rectangle is a special type of parallelogram where all 4 interior angles are equal to each other. All right, I'm quickly going to scroll back up to parallelogram so that those who didn't get it can take a screenshot. So let's grab that screenshot. There we go, parallelogram. All right, so the next shape we're going to have a look at is a rhombus. So start thinking of your rhombus or rhombi characteristics. So rhombi is the plural, rhombus is singular. What look like? Rhombus characteristic?
All sides are equal.
Okay, so what's now unique for a rhombus is that all 4 sides are equal. Alrighty, so unlike the parallelogram and the rectangle where opposite sides are equal, now we have all 4 sides equal. Very nice. Luanle, what else do we have?
Ma'am, the opposite angles of a rhombus are equal.
Good. So in a rhombus, our opposite angles are equal. Which means that this angle is equal to this angle and that angle equal to that angle. Very nice. And Kululeko, what else do we have?
Ma'am, all sides are, ma'am, opposite sides are parallel.
Good. Our opposite sides are parallel. Omfa, just hang on a second. Sorry, I'm just panicking a little bit. There we go. Opposite sides are parallel. So again, a rhombus is a special type of parallelogram where all sides are equal. Umfa, what else do you have?
A pair of adjacent sides is equal.
Good. Okay, so guys, that all 4 sides are equal, we could also phrase it in that adjacent sides are equal. So all the sides next to each other are equal, which essentially means that all 4 sides are equal. Nice. I just want to make sure I haven't missed anything again on the chat, just making sure. Okay, again, all your interior angles do add up to 360. We've got our parallel, we've got our equal. Right. Making sure again. Okay, now guys, what's important about the diagonals for a rhombus is that they do bisect each other, but really importantly, they bisect each other at 90 degrees. So our diagonals bisect at 90 degrees. Okay, and that feature of them cutting each other at 90 degrees is a really important one when it comes to geometry later on in maths. So they cut each other in half, and importantly, they meet or bisect at 90 degrees. Right. Toriso, I'm hoping I'm saying your name correctly, has also added another characteristic here that these diagonals bisect the opposite angles, which is also perfect. Diagonals. I'm trying to give everyone a chance. So Obviously, please do raise your hand and please do give options. I am just trying to spread chances here. Diagonals bisect opposite angles. And so similar to like the kite situation that we had earlier, two angles would be equal to each other, and those angles would then be cut in half and be equal to each other. Okay, so hopefully what you can see is as we're starting to move down in our quads, we're starting to get more characteristics that are defining for that specific quadrilateral. All right, to take your screenshots, I'm lowering everyone's hand because I haven't actually asked anything yet, and we have our characteristics. We will get to the next one just now. Okay, so the last quad that we're going to look at, yes, indeed, is a square. And a square is sort of like the most specific type of quad that we look at. You're going to see now as we start to talk about the characteristics of a square, it starts to pull characteristics of your parallelogram, your rectangle, your rhombus, and it starts to make the specialized shape, which is our square. All right, so screenshots, start thinking about your square characteristics. Isaiah, so what happens is on Wednesdays, there's a quiz based on the week's work. And so that's where you practice it. We're going at a fair rate, so I'm hoping we'll be able to do 1 or 2 questions. The focus or the goal of this lesson, as I said at the start, is that you know the characteristics of quads. So we might have time to do an example too, but there is also a quiz at the end where you are asked questions based on what we've done. Okay, so guys, square characteristics. Hands up. Let's hear. I see some people already putting in the chat. Okay, Chantal.
Ma'am, all 4 sides are equal.
Good. All 4 sides are equal. So that's pulling from the rhombus, because we've just done the rhombus and we know all 4 sides in a rhombus are equal. So that's taking a characteristic from the rhombus. Omfa, you said you wanted to give a characteristic here. Let's hear. Omfa, you there? Okay, I'm going to move on. Lwandle?
Ma'am, opposite sides of a square are parallel.
Okay, I don't know who's talking. Who's talking right now?
It's me, ma'am.
Lwandle.
Yes.
Okay, sorry, it's 2 people unmuted. Umfa, I'll come back to you in a second. So yeah, sorry, Lwandle, to interrupt you. Carry on.
Ma'am, opposite sides of a square are parallel.
Good. So in a square, our opposite sides are parallel. So that's pulling from the original parallelogram. We know that that's true for a rhombus and a square as well. Okay, Umfa, let's try this again. There we go.
Ma'am, it has 4 right angles.
Good. Okay, so pulling from the rectangle, all 4 interior angles are 90 degrees. Which means, again, because we've got all of these parallel lines, we can say that adjacent angles are supplementary. We can start working with co-interior angles, but we have those 90-degree angles. Very nice. Isaiah?
Ma'am, the interior angles add up to 360 degrees.
Okay, perfect. So again, going off the purpley pink, if we now add up all 4 of those interior angles, we get our 360 degrees, a very important characteristic of our quads. I'm just going to pop to the chat because hands are still up, the people that we've asked. So I'm just going to make sure I haven't got anything here. Right, so again, diagonals, as you can see, diagonals are super important when it comes to quads. Diagonals have 2 characteristics that are important. So the first characteristic of our diagonals is that they're equal. So they're equal in length. And secondly, they bisect each other at 90 degrees. Okay, so 90-degree angle in the middle, and because the diagonals are equal and they bisect each other, all of those parts are the same. So coming from the rectangle sort of characteristic, but combining the rhombus characteristic of intersecting or bisecting rather at 90 degrees. Right, just making sure we haven't missed anything. Wanley, your hand's still up. Anything else?
No, ma'am. Sorry, I forgot to put it down.
Okay. Okay. So guys, the last one that I want to add here, if you go back to the rhombus characteristic, we said that the diagonals cut the opposite angles in half. The same is true for a square. So our diagonals bisect the opposite angles. Now, because all of the angles are 45 degrees, basically what that means is it cuts all those 45-degree angles in half. I just want to move this up a touch. All right. And so if it's cutting all the 45-degree angles, oh, sorry, guys. Okay, I'm going to sort it all out. Because it's cutting because it's cutting 90-degree angles in half, all of these angles are bisected to a size of 45 degrees. So all of the angles when bisected are exactly the same because all of the angles are 90 degrees. And if we're going to cut a 90-degree angle in half, we get 45 degrees. All right, so that is our square. Those are all the characteristics we need to know of our square. So again, take your screenshot. It looks like we are going to have enough time for at least an example, which is great. So you'll see how we can start to use these characteristics in a second. Take your screenshot. I'm just going to wait here. Does anyone have any questions before we move on? Omfa, I see your question. So why is a rhombus and a square the special type of parallelograms? So a rhombus, a square, and a rectangle or special type of parallelograms, because remember, the defining characteristic of a parallelogram is that both pairs of opposite sides are parallel and both pairs of opposite sides are equal. Those are sort of like the big main characteristics. That is then true for rectangles, rhombuses, and rhombi and squares. So they are just now more specialized parallelograms, more specialized characteristics that then form these new shapes that we have. Guys, any other questions before we have a look at an example? Alrighty, so just to give you an idea, this is sort of the idea of the family tree, and this is exactly what I said to Umpanam. Right, a parallelogram, if we just look at the parallelogram specifically, don't know why I chose a pen, let's do this again. So if we look at the parallelogram, it can branch off to the rectangle, the rhombus, and then combining those to the square. But these three shapes at the bottom all come from the parallelogram. So they are all parallelograms. They are just special type of parallelograms. And that's what the family tree shows us. All right, so I'll take off this gross highlighting in case you want a screenshot of the family tree. Obviously, like I say, the important stuff is knowing the characteristics. And so we've done those characteristics, you've taken screenshots, you know them. We now obviously need to be able to apply them. Okay. Please remember that we ask questions on topic, but I'll deal with all of this in a second. All right, so we're not going to do a brain break. We don't have time for that, but let's see how we can start to use these properties. So I'll give you a second to have a look at this. The question says, identify the quadrilateral and determine the value of A. So I want you to have a think. What type of quadrilateral is it? And can you give me A's value? I just have some questions that have been asked that I want to answer. Bit off topic, I was wondering if, okay, so I did say at the beginning that Watobe follows caps. Some schools do choose to switch the order in which they're teaching. So, for example, my school doesn't necessarily teach according to the caps order. At the end of the day, as long as at the end of the year you've taught everything you're supposed to teach, it doesn't really matter. So yeah, some of you would have done the work, some of you wouldn't have. Depends on how your school does it, but Watobe follows the CAPS guidelines. Canva, yes, they're all connected because they have some characteristics that they take from the other and they share those characteristics. Very nice. Okay, so guys, on the chat, what type of quadrilateral is ABCD? Based on just the information you have, what type of quadrilateral is it? Okay, so yes, we can say that ABCD is a parallelogram. And we can say it's a parallelogram because we have been told that AB is parallel to CD, and we have been told that BC is parallel to AD. So this goes back to what I said earlier. It is a parallelogram has two pairs of opposite sides parallel. So we can say it's a parallelogram. Now that we know it's a parallelogram, we can now use the characteristics of a parallelogram to answer the question, which is what is the value or what is the size of angle A? Now guys, remember, if we just quickly jump back to our characteristics of a parallelogram, one of the important characteristics we said is that the opposite angles are equal to each other. So if we go back to our example here, we can see that we have been given the angle opposite to A. So here's A. I've given you 135 degrees. And so we can say that A is equal to 135 degrees because opposite angles of, now guys, parallelogram is a very long word. You don't have to write parallelogram. There's two ways you can write it. Either you can say palm, that means parallelogram, or you can draw your parallel lines and then almost like an exponent, put an M. Both of those mean parallelogram. So opposite angles of parallelogram are equal. So because we used, or because we know what type of quadrilateral it is that we're working with, we can now go and identify or say what the value of A is. Right, now guys, we have just gone through all of the characteristics. So if you're struggling to differentiate, go back to your characteristics. But the difference between a parallelogram and a rhombus is that a parallelogram, the opposite side, or all sides rather, aren't necessarily equal. A rhombus is then a special type of parallelogram where all four sides are equal. So a rhombus, not all four sides are, a parallelogram, not all four sides are equal. A rhombus, they are all equal. Alrighty, let's have a look at one more. So take your screenshots there. Let's have a look at another. Okay, so now guys, this one's a little bit different because in this case, rather than asking you to identify the shape, I have already told you it is a parallelogram. So what's important here, when I tell you it is a shape, you can automatically assume that everything about the parallelogram is true. So we can automatically say, okay, AB is equal to DC. We can automatically say AD is equal to BC. We can automatically say that angle A is equal to angle C and angle B is equal to angle D. We can say all of these things because, sure, because it is a parallelogram. So because we know it's a parallelogram, we have now been asked to find the value of X. And this is what a lot of you, or this characteristic is what a lot of you brought up. Let's just go back to our straight line geometry that we did 3 weeks ago. And remember that, and it doesn't really matter which way you see the U or the C shape, there's 4 different ways. Remember parallel lines that with a transversal or with a line joining them forms this cup shape or C shape or U shape. What we have are co-interior angles. And so what that means is if we take the X and add the 125 degrees, we have to get 180 degrees. Those angles are supplementary. All right, so X plus 5 plus 125 must equal to 180. Now this is a geometric reason we have to give, or geometric statement, we have to give our reason. And our reason here is co-interior angles. And remember, you have to state your parallel lines. So AB parallel to CD. Those are the ones I highlighted. Right now we can solve for X. So we've got X plus 5 and 125 are like terms. So 130 is equal to 180 degrees. And so by subtracting 130 on both sides because of inverse operations, I get that X is equal to 50 degrees. Now guys, go and double check yourselves. You guys have told me multiple times that if we add all 4 angles in a quadrilateral, we must get 360 degrees. So if I now go and substitute that information in, 50 plus 5 is 55 degrees. That's then the same opposite it. Now, if we add all 4 of these up, so 125 plus 55 is 180. Plus 125 is a value that my brain can't compute right now, but I will do on a calculator. So 180 plus 125 is 305. Plus the last 55 degrees gives me 360. So remember, we've spoken about this before. You can always double check yourself when you're solving for an unknown by putting it back in and making sure that it's true for the knowledge you have about that shape. All right, so I'm going to stop, take your screenshots. If anyone has any questions, you can raise your hand and ask me. But guys, this is essentially how we take all of those characteristics that we learned and we start to apply them to questions. So where I start to give you values and I ask you questions about the specific quadrilateral.